Hey there, everyone. My name is Ryan Schubel. Welcome to my data science channel. In the project today, I want to look at targeted advertising and targeted marketing campaigns and try to understand how to optimize the budget or the spend for different types of communication channels that we're going to try to reach a customer and convert a potential customer to an actual money spending customer. So we can understand click-through rates and conversion rates. We can segment our targeting using clustering techniques. We can understand campaign performances. We can measure and understand A/B testing. So A testing would be, what about this option over here? B testing would be a slightly different version over here. Which one is more effective in reaching the customer? We can look at funnel analysis, where we have a bunch of potential customers going into a funnel and possibly converting them into an actual paying customer. We can understand behavioral clustering, and then things like device specific or geographic specific trends. So is somebody engaging with us with a mobile device or a laptop? Or what part of the country are people located in, and where are most of the people or most of our customers located, so we can reach them more effectively when we understand this, right? So let's also take a step back to understand the differences between marketing and advertising. So marketing is like big picture strategy, everything, the whole universe of the budget that we're spending to reach people. Long-term, multi-channel, so very complex, convoluted, includes research, branding, et cetera, covers a full span or full gamut of the customer's journey. Advertising, on the other hand, is a little bit more tactical, promotions, specific promotions, usually short-term, paid interactions with the customers to reach the customer there. Focuses on messages and promotions, and targets awareness and eventual potential conversion of this customer. So let me go ahead and create some data here. I looked online for something that might be interesting. I couldn't find it, and I didn't want to spend tons and tons of time doing this exercise. So I'm actually going to create my own data, and it's going to have demographic information and some information about devices, location, the country, things like this. So we have customer ID, age, gender, income. Has the ad been seen? Yes or no. Has the ad been clicked on? Yes or no. Has an email been opened? Clicked, pages viewed. Time spent on site. Bounce. This is when a customer will come to the site but then bounce away. They don't really interact or spend a whole lot of time there. Converted is the opposite, where somebody comes to the site, they give us money. That's sticky money. It's going to stick, and that is going to help our business. Campaign source, device, so tablet, mobile, desktop, the country where the person is located, and is there any session duration in seconds? Like if the person spends more time on the website, are they going to spend more money with our business, or are they going to buy more stuff from our business? So I created this data frame. I think this is pretty interesting. We have some demographics here, click-through rates, time spent on site, device type, country, location, and so on and so forth. So I want to go ahead and do a clustering experiment right here. I'm going to segment all of our customers into 10 different clusters. So 0 through 9, we always start with 0. We go up to the number of clusters minus 1, because we start with 0, we don't start with 1. And I'm going to look at these features right here. So I think these are important to understand how effective this advertising or marketing campaign is going to be to interact with the customer and to engage with the customer. So I'm going to look at age, income, has the ad been seen, yes or no, clicked, email, pages viewed, time on site, bounce, yes or no, converted, and session duration in terms of seconds. So these are all the variables or all the features I'm going to look at and try to understand which clusters these customers are going to fall into. So here's the number of records, right? 5,000 rows, 70 columns. We see age, gender. We see the demographics over here. Originally, we had up to duration seconds, right? Session duration seconds. Now we'll have one new column added to the data frame. This is cluster number, so it's a 0, 5, 7, 8, 9, things like that, right? All we do is take the cluster, KMeans fit, put the scaled data, as data scaled. So anything that's outlier or extreme example, it's brought a little bit more into the centroid, closer to the center of the cluster, so we can work with the data better, right? So you always want to scale all of your clustering data. Scaling is very important for clustering, right? To pull in the outliers and pull them back into towards the centroid or the center space for that whole cluster, for all the segments in the cluster. And you don't always have to scale all your data, but when you're doing clustering, it really is good practice to scale it. So now we can plot visually and assess how different use clusters behave in terms of ad interaction and conversion, right? From a potential customer to an actual customer, are the users who click ads likely to convert? So that's what you would think, right? If you click on an ad, the person is probably going to make a purchase and become a customer because they're interacting with the ad, right? They're curious, right? So we're going to group by all the click ads and converted and take a mean. So this is an average of all of the clicks, right? So when I run this, we will see. Oh, let me add something here. I always like to make this like a little bit, take up the whole space, on the page, just to make it a little bit wider and a little bit taller. So you can see here, did not click, and then clicked. So about 11% of the people clicked on the ad, and we converted those people to customers, and about 15% of people did not click on the ad, and we converted those to customers. So the first time I saw this, I thought, was the analysis correct? Did I make a mistake? Did I do this right, or was this wrong? Because how can you have a conversion rate higher for people that did not click the ad than for people who clicked the ad? That sounds a little bit counterintuitive, but in actuality, higher conversion rates might not be indicative of ad clicks. Okay, there's a few reasons for this. There's a self-selection bias. Perhaps people who clicked an ad might just be curious, right? So you click an ad to see what it is, but you're not really planning to make a purchase anyway. You're just curious to see what that ad is and what it contains. But they're less serious about making a purchase, right? They browse, but they don't convert. In contrast, some people might already have made up their decision. They don't need to click the ad to make a purchase, right? Maybe they're just going to go straight to the Amazon shopping cart, make the purchase because they already know what they want. They don't have to spend time watching several ads to help them make up their mind. They already have made up their mind, right? Poor targeting or bad creative ideas. Some ads are just bad ads and people don't want to interact with that, so they're not going to click on it. So maybe the person doesn't click, but they're still going to make a purchase, right? And there could be an attribution mismatch where some conversions may not be attributed to ads properly. This could happen in multi-channel attribution systems where you'll have lots and lots of different channels, right? And you click on one ad, but you actually buy a different product, right? So there could be a dislocation or like a distancing between what the person intended to do by clicking on the ad, but that was an accident, but they already knew what they were going to do in their mind. They were going to make a purchase, whether the ad was there or not. So we can look at certain clusters, look at the mean, the count, and the mean of the clicked ad, the converted mean, and then the customer ID count, and try to understand of all the cluster stats that we're creating right here. This is called cluster stats. So this is small data frame. That goes down here to our scatter plot. That becomes basis for the scatter plot. So we create the data frame, put that into the scatter plot, and look at the CTR. This is a conversion rate, and the CTR is going to be on the x-axis. So this is one of the fields in the data frame. If we go back here, where is it here? No, actually it isn't. So wait a second, give me a second. So CTR is CTR. I did this code a couple days ago, so now I actually forgot where it's coming from. Oh, okay, click ad. So it's just clicking the ad and are making a conversion. So we're renaming columns as clicked ad. That becomes the CTR. This is the horizontal axis for the X plot, and the Y axis is the conversion rate. So here's the Y variable, here's the X variable, CTR. Let me get rid of this and plot the chart. Okay, and again, you know what? I want to put that width. I like it to take up the whole width of the screen and to make it pretty broad too, pretty high too, so it's easy to see. So here we have the click-through rate. CTR is a key metric for digital marketing that measures how often people who see an advertisement, right, to have some exposure and some motivation to make a purchase, will actually click on the ad. So a lot of times ads are presented to people and they never click on it, but if you click the ad, that's called a click-through rate. So the clicks are the number of times that the ad or link was actively clicked, and this could be anything. The ad could be shown 100 times, maybe it's clicked once. It could be shown 100 times, maybe it's clicked 50 times, okay? But it's probably gonna be somewhere in between maybe 5, 10, 15, 20% max. I don't think it's gonna be higher than that. A lot of times people know what they want. They don't need to be exposed to the ad. They're gonna make the purchase no matter what. And then sometimes people are gonna click in the ad and they still won't make the purchase. But that's what we're trying to quantify right here, right? So clicks divided by impressions. Impressions every time an ad was flashed at you or shown or displayed. And the clicks are the number of times the ad was clicked divided by impressions. If you have 100 impressions and 25 clicks, the click-through rate is 25%. So the higher the click-through rate, your message is engaging and relevant. So we can measure if the click-through rate is higher, then these ads are good. If the click-through rate is pretty low, we might want to talk to the people in the ad bar and say, you guys have to get more creative, or identify the customer better, understand the needs of the customer better, so we can cater to that, right? So the higher the click-through rate, the better for the business. Low click-through rate, you might need to improve targeting, design, call to action, like I just said. So here's the first cluster, cluster 1. We have a click-through rate of 0, but a conversion rate of 17. So nobody clicked the ad. People already knew what they wanted. Same thing over here in cluster number 2. You can see a cluster number at the bottom. You see as click-through, conversion, customer ID, cluster number 1. So same thing down here, cluster number 2, click-through rate 0, and the conversion rate is slightly lower. This is 15%, this is 17%. So again, cluster 0, click-through rate 0. Now conversion rate is a little bit lower, 14%. Here we have cluster 3, click-through rate is actually 14%. So the ad was displayed 100 times, 14 times people clicked on that. And the conversion rate of the people that clicked on the ad was 12%. And over here we have cluster number 4, click-through rate was 100%. That's kind of rare, but you could see that maybe the ad wasn't delivered too many times, or the what was it called? The impression. Maybe there wasn't many impressions, maybe just 10 impressions. 10 people clicked on it, so the click-through rate was 1, conversion rate is 12. And we have the customer ID, of course, and then cluster 4. Okay, so now we can kind of see how these customer segments are broken down and who is more responsive to the ad and more likely to click through, and which customers just don't even care about the ad. They're going to make a purchase regardless of what they saw. So we're going to do something similar here, high-value clusters. Like you saw before, we create a data frame, feed that data frame into a plotly bar chart. Okay, and the x-axis is going to be the cluster number, and the y is going to be the average income. So we have mean income, converted customers, and count of customer ID. When I plot this, you'll see the bar charts. So here in cluster 0, conversion rate is 14%, average income 85K, conversion rate 17%, 83K income, conversion rate 15%, cluster 2, 12% for cluster 3, and then for cluster 4, about 12%. So all the time it's a 12% to 14%. That's pretty normal. I would say maybe 12 to 15%, 12 to 20 on the high side. That's pretty normal though. But the conversion rate is basically a key metric of performance that tells you what the performance of users takes to engage with a certain action. This is called the conversion, out of the total number who had the opportunity to make the conversion, right? And again, the conversion rate is conversion divided by total visitors or clicks times 100, right? We saw a similar metric right over here. Click through divided by impression times 100, right? So moving on, let's look at a feature importance exercise. So when we do this, we can see which features have the most statistical influence or impact on the target variable. So I am setting the churn as a target variable. So churn is customers are churning away or going away. They're leaving your business. Pretty much everybody knows this. If you have a customer that's brand loyal and they stay with you, that's worth infinitely more than you going out to try to find a new customer, because you're going to look for 100 and maybe you can convert 1, maybe 2%. It's going to be harder to find new customers than it is just to keep the customer that you already have, right? So keep the customer happy, fed, watered down, right? And as long as they're content, they're going to stay with your company. If you have to go look for new customers, there's going to be a big effort, a lot of labor that goes into that. But I want to see which independent features right here have the highest statistical impact on whether or not a customer will churn. So we can look at age, gender, income. Has the ad been seen? Email opened, right? Email opened, has the email been clicked? Pages viewed, time on site, bounce, right? So the customer comes in and goes away, doesn't make a transaction, and session duration in terms of seconds. So that's what we're looking at here. So these are the independent variables. This can be anything, right? I want to see of these variables, which one causes the customer to stay or to leave. That's the churn. So let me hit Control Enter, and we are using a random forest classifier, right? We're classifying all of the outcomes as either important or not important, and to what degree are all these outcomes important, right? So if you don't understand all the machine learning, that's okay. I'm not going to take you through everything. This is more about advertising and marketing today, and we're using a couple ML algorithms to help us achieve our objective. But go ahead and research random forest classifier. You'll find a ton of information on the web, and I have a few videos on my channel that cater exactly to machine learning. Several, actually. There's quite a few at this point. I have like 320 videos now, and several of these are specifically dedicated to machine learning and what does this actually mean. So we have the feature and then the importance of that feature in predicting whether or not a customer will leave. Time on site, 36% of the time, that is going to determine if a customer is going to stay or leave. Pages viewed, 0.23% of the time. Open email, 0.14. Income, session duration, seconds. Age, gender, click, ad scene, and bounce don't have a big influence on whether or not the customer will stick around or whether they'll leave. So we have the importances, right? I just created that data frame. If you go over here, you'll see it. These are all the importances. This is the feature and the probability of that feature impacting the having that statistical impact on the target variable. So I plotted everything here just visually so you can see it. I mean, it's pretty obvious right here. The top three are time on site, pages viewed, and email opens. But I like to create a chart just to visualize it and just to draw the user in. And I always say a picture is worth 1,000 words, right? So you can see how this matches up. This is 0.3627. That matches perfectly with this over here, 0.3627. The next highest is 0.2322. You see that right here, 0.2322. And then the third highest is 0.1407. So 0.1407. So we're taking all the features, just flipping it sideways, so we have a horizontal bar chart, and we can see the degree of influence of each feature impacting the statistical, impacting the target variable and what kind of statistical influence we have on making a prediction of how accurate that target variable is going to be. So time on site, that makes sense. The more time you engage in the site, the more likely you are going to make a purchase or stick around with the business for future purposes, purchases. Pages viewed and emails opened. So the income of the individual doesn't really determine if they're going to stick with the business. That makes sense. Like, who cares how much you make or don't make? That's not going to drive the business. The session duration in terms of seconds. So how long do you stay on the site? That's similar to pages viewed. I thought that would be a little bit higher, or time on site. But session duration gets a little bit lower importance, and that's fine. Age of the customer almost doesn't matter. And if you think about it, I don't care if the customer is like 18 or 30 or 50, how does the age of the customer impact how much time they're going to engage on your site? It really doesn't. It has almost no influence. But it does have a small influence at 7%. The gender doesn't matter. Click email, ad scene, and bounce really don't make up too much of the importance of whether or not a person is going to stick around and become either a what do we say is an independent variable, either churn or not churn, right? So hopefully that makes sense. I think that's pretty intuitive. So let's look at the recommendation engine at this point. So moving away from the feature engineering or feature importance, sorry. So we're going to look at collaborative recommendations. There's a few ways to make recommendations. Okay, I have a whole video devoted to that on my channel. You can check that out. So in this case, we're going to look at collaborative recommendations, and we're going to see if a customer can be converted. And based on the campaign source, we're going to try to understand how to make recommendations to future customers. Let's say you're friends with Sally and Bill and Tim, and you guys have a lot of things in common, right? And your name is Kim. Maybe Kim will make a purchase because she's friends with Sally and Bill and the other guy I just mentioned, Tim or whatever. So if they have a lot in common, they'll probably make a purchase. Or, Tim likes this style of music and this type of food, and you're friends with Tim, so you'll like the music and the food. That's what we're looking at here. So there's a couple ways to make recommendations: collaborative recommendations and content-based recommendations. So let me go ahead and hit this, and we are going to get the cluster. and merge DF simulated with collaborative recommendations. If I do Control F, you'll see that is the first data frame I created, and content recommendations is the second, right? And we're going to combine that with DF simulated. So if we go back here, DF simulated comes from the original data frame that we worked with, and combined equals this, okay? So we're taking collaborative recommendations, merging that with the original data frame, DF simulated, creating combined and combined with content recommendations. So we're taking these two types of recommendations, collaborative recommendation, content-based recommendations, and merging that with the original DF simulated data frame. If I go back, I will show you what that looks like at the top. DF simulated is the original data frame that we had over here with all the demographics, converted device, time spent on site, and so on and so forth. Okay, so we're looking good. I skipped ahead a little bit, sorry. So we have, I skipped ahead a lot. Okay, so we combined everything, collaborative, content-based with the original DF simulated data frame. And if we look over here, we can see what we end up with. Device counting, that's what we started with, session duration. Now we have the cluster, that's what we did a few minutes ago. Then we have the churn of the customer. Are they going to churn or not churn? 0 is stick with us, nothing happens, that's false. If it's a 1, then they're churn, then they leave and we're turning customers away. So we look at the top campaign by customer and the top cluster for the product. So at this point, keep in mind collaborative filtering groups the data by campaign source, like email, social networking, searching, things like that. For each campaign source, it finds the most common clusters that are interacted with, okay? What's been viewed, clicked, converted, okay? And this is extremely useful for targeting for customers, for campaign planning, and for personalization and making a custom design ad specifically for that user. So that's very common. You can have ads that cater to maybe older people, ads that cater to younger people, ads that cater to the more affluent, ads that cater to the less affluent, right? So you can cater your ad or customize your ad to reach different type of demographics. So over here, we're going to look at a couple different metrics here and see what is the campaign effectiveness, okay? So if DF simulated, so data frame simulated campaign source, if it equals email, and converted, this is an email conversion. If we have campaign source and social converted, this is a social conversion. And we're going to look at the conversion rate of each. So email conversion, about 14% for all the emails we send out. If we put an ad on Facebook or TikTok or maybe LinkedIn or something like that, about 13% of the time, those potential customers are actually converted to actual customers. So now we're looking at device and desktop clicked ad versus desktop mobile clicked ad, and look at what percent is converted there. Desktop 30%, mobile 31%. So pretty close. So I wouldn't have a preference of advertising on either mobile or desktop. It doesn't matter. And email or social conversion rate, those are pretty close. So it doesn't really matter which campaign you choose. Let's look at another example. Email opened and the person's converted, email open and not converted. 0 is not converted, 1 is converted. And email open actually has actually slightly lower conversion rate than email not opened. But again, I think that goes back to saying the person doesn't have to open the email. They already know what they want. They've already made up in their mind that they're going to make a purchase with us. They bypass the email. They don't care about it. Okay, so it looks a little bit counterintuitive, but that's how that works. So now we can look at country. US converted or country Canada converted. So US, we have slightly lower conversions, and Canada slightly more, about 2% higher. So maybe we should be running more ads in Canada and fewer ads in the United States, right? You get more bang for the buck in Canada. Let's look at geolocation-based targeting of ads. So we get everything from the original data frame, DF simulated, converted, clicked, email opened, and customer ID. So we know who these customers are. Right? And with the customer ID, we're just going to have an abstracted away ID or a hashed ID. It's called hash. You don't have the person's actual name or address or something like that. That's PII, personally identifiable information. Nobody gives out PII. That would be cardinal sin, right? You don't want to identify your customers by the first name. You could actually know that person, or you can know somebody who knows them. And now all of a sudden you have access to their income, to their spending patterns, to the profile of the individual. That should be anonymous, right? You don't want to know your customers. You want to have an ID. So if you have to identify it, you can track back, you can map back to the customer. So we will capture the ID, but we're going to hashtag the ID. So it's a series of letters and numbers that represents the person's name or maybe cell phone number or email address. Email addresses and cell phone numbers are unique. People's names are not unique. But the point is, like, you want an identifier so you can map back to this person if you need to, but you're not going to report on that. So here's the conversion rate, click-through rate, email open rate, and then user count. Okay, so we have a nice little matrix here, and we see the conversion of each. So 15, 15, 14, 14, 13. Click-through rate, this is actually higher, 30, 31, 29, 51. So email opens is actually pretty higher in US, about 48, pretty close. And then the user counts, okay? So let's take a look at time of day and seasonality trending. So I'll go ahead and parse out the from the session start. If you go over here, so session start looks like this. I think, is it actually, was that created down? Let me see. Oh, I see. It's creating it right here. Okay. So some of this data, basically all this data was made up. I tried to make it as realistic as possible, but I didn't really find the exact data set I was looking for. I wanted the demographics, the click-through rates, the ability to make A/B testing, but I couldn't find the exact data, so I created it myself. So now I'm creating a session start date when we start to first engage with the customer, and based on that, we can pull out the hour, the date name, and then the date month name. Okay, we'll put that into different features in the data frame. So we have hour, day of week, and then month. And if you go over to the right, you'll see that. So here's hour of the day. So you can see 2200. And this was a Monday, and this was October. So here's October. I can tell you it's October. And here you see 7 o'clock in the morning, right? And here's 7. This is a Saturday, and this is August. So August is the 8th month. So that's fine. So let me, this thing looks a little bit weird coming on. Okay, I like to make it so the graph takes up most of the space on the page. I think it just makes it easier to read. And why waste space? If you have it, you should use it, right? And let me put that down here too, because that one is kind of condensed unnecessarily. So now we have the conversion rate by the hour of the day. So we can see conversion at midnight is about 13%, drops down a little bit, down to 12%. So people are sleeping by 2 o'clock in the morning. Some people are waking up at 3. That's a little bit weird, but that's what the data tells us. Conversion rate drops down a little bit, and then into the morning, into the afternoon, these are the conversion rates over here. Actually, the reason it looks a little bit weird is because that was kind of made up and I used random numbers. So again, I kind of had a vision in my mind what I wanted this to look like. I couldn't find the actual data. Probably, if you can find this, the conversion rate is going to dip down as people are sleeping. They're just not buying stuff at 4 o'clock in the morning for the most part. And then as people start to wake up, they will engage with the website a little bit more, start to make purchases, probably go to work, probably dips down during the afternoon. And again, in the evening, when people are coming home from work, probably goes up again. And then 11 to 12 o'clock at night, it's probably dipping down. So this is kind of realistic, except we have a big spike here about 3, 4, 5 o'clock in the morning. That is not expected. But again, the data was literally made up randomly. So it's fine. Like, we're just reporting what we've got. If I could find the data I wanted, I would use it. I couldn't find it, so I just made it up myself. So now we're looking at day of week, and then the conversion percent for each one. Sunday, 13, 12, down, now we're up to 15%. Tuesday, Wednesday, Thursday, Friday. People are shopping Friday, jumps up a little bit Saturday. And this is by the month of the year. Okay, so this is a conversion percent by the month of the year, January through December. Okay, so hopefully this makes sense at this point. Let's look at morning conversion versus an evening conversion. So again, looking at hours between 6 a.m. and 11 a.m. and evening 1700 to 2200, so military time, right? So morning conversion is about 13%, evening conversion is about 16%. So more people are interacting with the site and making purchases and transacting with our business in the evening versus the morning. So in the evening time is when we should be running more ads. So at this point, let's look at ad spend optimization. So this is what I alluded to basically at the beginning of the presentation here. So how can we optimize how we're spending money on these campaigns, right? Because you can spend a lot in email, a lot in social networking, Facebook, TikTok, LinkedIn. You can spend a lot in search, right? Referral, display, all these things. But which ones give you the most bang for your buck? Where are you wasting your money? And which campaigns are delivering the most value in terms of converting potential customers to actual customers? That's what we're going to try to analyze and answer next. So we have some setup information over here. We're converting everything into a data frame. So we have channel, chemicals, channel, why is it getting tired? Channels, optimal spend minimum, with minimum engagement, ROI per dollar, conversion rate, and cost per impression. So we have that nicely ordered in a structured data frame right here. So let's go ahead and report on that. So we have DFROI right here. That comes from the previous step. Or not from the previous step. We have the data frame constrained. That is displayed here. We're going to create the ROI. Okay. So the channel conversion rate, cost per impression, and then ROI per dollar. And then we have the DF constrained right here that we are plotting on. And the DF ROI goes where? Let me see this. Replace with your optimized outputs. I don't even know if we're even using that. You know, when I was testing the code, I think I developed that and didn't actually utilize this thing right here. But that's fine. That's fine. It's probably superfluous. I'll just comment that up. Maybe we need it. Probably we don't. So let me save the change here. So we're going to go ahead based on DF constraint, sort based on the X channel being the X-axis and the Y channel being the ROI per dollar. So let me just go back a second. Where's DF constraint coming from? Oh yeah. So here's ROI per dollar, right? So that's the Y-axis, and the X-axis is going to be the channel, okay? So now we can see which channels deliver the highest ROI. Display gives us a 30% ROI, channel referral 25%, email 15 for social network, and search is about 13.3. We can break this down exactly the same data, just in a pie chart as opposed to a bar chart. So we can see the breakdown here, 30% versus 15, 3.6, 13.6, and 25, okay? And I use the same width and height. I like those variables right there. I like to set it so it takes up most of the space on the page there. Okay, and now we can look at Plotly in terms of ROI per dollar, the conversion rate, and the cost per impression, and look at the heat map to see how all of these features combined together, right? So what's the ROI versus the conversion rate versus the cost per impression? So cost per impression per email is about 40. You can see here the darker blue, the more bang for the buck, the higher the value. This is 60%. This is 30%. So anything yellow, we're not getting as much value add for the money that we pump into the campaign. And if it's dark red, like 0.1, 0.06, this is 6% ROI, 4.5%. So this is really the best right here. Search cost per impression, 60%. These are probably the worst. Conversion rate, email, social network, search, referral, and display. Just all the conversion rates across the board are not desirable. The cost per impression, a little bit more value add, a little bit more bang for the buck. And the ROI, you can see, goes from 0.15 to 0.30. So this is an interesting way to look at a three-dimensional data set, ROI per dollar, conversion rate, cost per impression, with the what is it? The X is the X is the campaign, and the Y is the ROI numeric, and then the Z is going to be the color, right? So this is an interesting way to get not really a three-dimensional plot, but plot 3 data points simultaneously. Most of the plots you see are two-dimensional. You'll have the X-axis and the Y-axis. You can create like a cube or an interactive sort of plot where you can drag it around and interact with the cube. That's a different type of plot. This is also a three-dimensional plot. These are somewhat rare. You don't see it very often, but it can be very informative too, because you have 3 dimensions that you're plotting simultaneously in the same space. So ROI, conversion, and cost for that campaign, right? So 3-dimensional plot. So this is the non-optimized ad spend. So the cost per impression for email is 0.4, social is 3, search, display, direct, and referral. So if we don't optimize the advertising campaign or the marketing campaign, and we just start blasting out emails to random people, social network, we're spending randomly, search random, display, referral, and direct all random, right? We don't really know or understand the customer base very well. And that happens a lot more than you think. And that's unfortunate because you waste a lot of money, you waste your resources. You just randomly sending emails to people that probably don't even care about the product, right? You really want to understand your customer base and target those people specifically, right? But here's the DF random with the spend, cost, impressions, conversion rate, ROI, and then the results, ROI per dollar, cost per impression, and then the conversion rate, 16, 13, 14, 15, and 14%. So we want to look at, we want to merge the DF constrained with the DF random, right? So the DF random comes from here. That is the data frame that we just created. And let me see, the DF constrained comes from over here. So actually, no, that's not the original source. Let me go back to the beginning. Okay, so that comes from this data frame that we saw just prior, right? The channel optimal spend, ROI per dollar, conversion rate, cost per impression. So that's the DF constrained. Then we created a random data frame. Okay, so that is right here, DF random. And we're going to take these two and merge them together. This is the DF constrained and the DF random. We're going to merge together on channel. So the channel is the common element between these two. We can do the merge based on the channel and basically combine these two data frames together. Then we can go ahead and plot the results. So we have DF compare. So we have the constrained, the random. We renamed the combined data frames into one single data frame called DF compare. And we're going to plot the results based on that. So you can see DF compare channel is going to be on the x-axis. DF compare optimal spend with minimum budget or minimum allocation to the budget versus the DF compare channel on the horizontal axis and the DF compare spend, which is going to be the random spend. Okay, so this is random. We don't really understand our customer base and we're going to waste money. The optimal spend, we already identified the customers, who's going to interact with the business, who's going to engage, and who's going to be transformed from a potential customer to an actual customer. Okay, I know it's convoluted. I know it's complicated. I get it. I spent a lot of time putting the code together, and I was scratching my head. I had a couple bugs. I had to debug it, and I went down a couple rabbit holes and went in the wrong direction, but then reoriented myself. So basically, here when we plot this, we have the optimized spend in blue, and then kind of the suboptimal spend in red. Email should be $1,000 spent. The suboptimal random spend, we spend almost 6,000, so almost 6 times more to reach these people, but it's all wasted. I get these emails all the time from people. Do you want to buy this product? Do you want to buy that product? No, I'm not in the market. I'm not going to buy your product. You're wasting your money. You spent $6,000 to send who knows how many millions of emails to people. All you have to do is target the audience that is going to respond to that email. They're going to react to that and they're going to make a purchase. Here, this is 6 times inefficient. So the social network, we say about 1,000 people will, we spend $1,000. That's a spend. Here they spent $42, but here you spend more money, but you're going to get a lot more people responding to your ad. Here, there's almost no spend, and nobody's going to respond to the ad because nobody even sees it. Here, again, we spend $1,000, and we're going to get a bunch of customers reacting to our ad. And here we spend $597, almost $600, but nobody is going to respond to the ad. It's total waste. Here we spend $1,000. Again, we're taking this and slicing it pretty equally across the domains. Not sure why it's 1,000 though. Let me see. Let me go back here just for a sec. Was that optimal spend? Right, looks a little bit weird, but I think that's fine. I think it's fine. With min, okay. Well, is that the original? Trying to find the first optimal spend. Optimal constrained. Oh yeah, it comes from here, right? That's fine. I'm not even gonna touch it because I use SciPy Optimize to get the optimal allocation. So if it says it's $1,000 per campaign, then I'm gonna trust this, right? Because I set the constraints on this. So ROI per dollar, this is the conversion rate divided by the cost per impression. I think I skipped over this when I was going through it before, but this is how we optimize the entire budget. Um, with the budget being minimum spend per channel 1,000 and the total budget is 10,000. So that's how we get that 1,000, right? So the minimum is 1,000, but we're reaching all the people we need to reach with this $1,000. We can spend 10,000, but we're not going to get any more. We have four budgets or four, 1, 2, 3, 4, 5 channels, right? So we can spend 5,000 and reach all the people. In the non-optimized budget, it's going to use the whole 10,000, right? It's going to use everything that it has, but all you need is 5,000 for each of these five channels, right? Each of these five campaigns. So the optimal solution is the most effective, and it's the one where we're using the least of the budget, right? So 1,000 was spent. In this case, 6,000 was spent, but all we needed was 1,000 here. 1,000 was needed. We way underspent here. 1,000 is needed, slightly underspent. Here we need 1,000 and slightly overspent by about double. Okay, so we have the optimization, we have the optimal allocation per campaign. Now we can compare ROI before and after optimization, and we'll define a function to compute ROI. Okay, so here's the calculation. Compute, wait a second, random spend. What doesn't like that random spend? Okay, so I think this was changed to spend. I think that's why. I'll see if that was it. Display. Okay, so it doesn't like display. So let me see. Okay, let me see where display is coming. Where's it even getting the display from? Okay, so I'm gonna go up here. Yeah, it's something totally different. Display. Okay, so display is there. Display is there. 0, 1. Oh, that's weird. That's weird. So display doesn't exist, but I think that is a display constraint. That's totally different. Okay, we have the optimizer. Search social display. Search referral. Email social search referral. I think I got chopped off here. Channels. The display is there, so this is weird. So something got changed here. I'm not sure what. I think I'm just going to take this offline because I have to debug it. I see display. I don't know why it doesn't filter down to the end here, but I will fix that bug before I post the video. I'll post the video later today, and that doesn't work too. Yeah, I don't know what happened here. So display is truncated off. It doesn't even exist there, so I think it's fine. The last time we saw it was over here. Something got cut off because we do have the display, but I don't know what. Cost per impression. Email social search display referral direct. Email social search referral. Oh, let me try this. Direct. So those are 4. Okay, so I can't debug it. I will go back and take this offline and fix it, and then I'll post the updated code for y'all. Oh, and I took it out of that. Well, it worked yesterday. I don't know what happened here. Maybe I was just messing around with it and dropped off. Let me try one more thing. Control. Correct. Oh, that doesn't work. Okay, you know what? So okay, so that, right? Okay. No. Sorry, that's totally wrong. Yeah, no, this thing worked totally fine yesterday. So let me take it offline. But in the end, you will see that the optimized campaign um, spend is once you optimize how you interact with your customers and identify customers and target those customers, you're going to spend about half of your budget, and the ROI is going to basically double. I'll prove that to you. I'll fix up the code, take it offline because I have to debug it. I'm not sure what happened to that direct campaign because this totally worked yesterday. I don't know what changed, but that's how it goes sometimes, right? There's little gremlins in here that live and they run around and mess up with your work. So that's it. Targeted advertising and marketing and how to optimize the whole budget. I will fix that bug and I will post the working code, the fully working code. I guarantee it'll be 100%. Sometimes during the demos, things go sideways. You can't always control that, but I'll fix it up and I'll post the fully working code 100% guaranteed later today when I post a video. Thank you for your time and I'll see you guys in the next one. Take care. Bye.